Morning, everybody. Today we are working on the exercise 7C, and this is the fourth episode on that exercise. And the exercise is about the tangents and the normals. The main topic is differentiation. This is the course book of the Pure Mathematics 1. And today we are going to solve exercise 7C. We will start from the question number 13. And let me raise this. This is exercise 7C and question number 4. Okay. So today the first question we are attempting is exercise 7C, question number 13. And this is the fourth episode on this exercise. The curve y is equal, there is a curve given. The y is equals to x into x minus 1 into x plus 2. And he says crosses the x-axis at the point 0. Here a point 0 is given, which is 0, 0. Then a point A is given, which is 1, 0. And then a point B is given, which is minus 2, 0. He says the normals to the curve at the point A and B meet at the point C. Find the coordinates of the point C. So we have a normal at point A, normal at the point B, and they meet at the point C. So we have to find the coordinates of the point C. So first of all, what we will do, we will derivate this, we will take this equation, x into x minus 1 into x plus 2. So this will become x into, this is x square, plus 2x minus x plus x is left, minus 2. So it will become x cube plus x square minus 2x. Then I will derivate it. Dy by the dx will be equal to the 3x square plus 2x minus 2. So at this point, at x equals to 1, the dy by the dx will equals to 3 into 1 and its square plus 2 into the 1 minus 2. And you will have 3 plus 2 is 5, 5 minus 2 is 3. So the gradient of the normal will be minus 1 by 3. Reciprocal of it, and you change the signs. Because the normal is perpendicular to the tangent. Now I will find the coefficient of the normal. That is y minus y1 equals to m into x minus x1. So y, I'm using point A. So y minus 0 equals to minus 1 by 3 into x minus 1. So 3y is equals to minus x plus 1. So this is the equation of that normal, okay? At the point A. Now, so now we will find the normal at the point B. So let me write here so you can understand it. Let me write here. So at x equals to minus 2, the value of the dy by the dx will become 3 into minus 2 plus, I can write it like this, 3 into minus 2 square plus 2 into minus 2 and minus 2. So it will be 3 into 4, 12, minus 4, minus 2. It will be minus 6 or 6. So the gradient of normal will be minus 1 by 6. So now I know the gradient of the normal at the point B. So we can find the equation of the normal. Equation of the normal at the point B. That will be y minus y1 equal to m bracket x minus x1. This is the point, and this is the gradient of that normal. Okay, so it will be y minus 0. Gradient is minus 1 by 6. X minus minus plus 2. So you will have 6y equals to minus x minus 2. Okay. Now we know the equation of the normal at the point A, and we know the equation of the normal at the point B. So we can find their point of intersection. They said that the normal at the point A and the normal at the point B intersected each other at the point C. So we have to find the coordinates of the point C. So we know the equation of the normal at A and the normal at the B, and we will solve them simultaneously, and we will try to find out the point of intersection. So the normal at A is 3y is equals to minus x plus 1. Simply add these. You can do, for example, I can subtract these. So 6y minus 3y will be equals to minus x minus 2 minus x plus 1. So you will have 3y is equals to minus x minus 2 plus x minus 1. So 3y will be equals to this, and this is gone, so minus 3. So y will be equals to minus 3 by the 3. So y will be equals to minus 1. Now I know the value of the y. I can put here. Okay, 3 into the minus 1 is equals to the minus x plus 1. So minus 3 equals to minus x plus 1. Bring the x here. Take the 3 to the other side. So the x will be 4. So the C coordinates will be 4, comma, minus 1. This is what I think is the answer. The point of intersection of the normal at the point A and the normal at the point B, that will be 4, comma, minus 1. Let me check the answer. This is the 4th episode on this exercise. And in this episode, we have started from the question number 13, exercise 7C. The topic is the tangents and the normal. And the main topic is differentiation. So question number, exercise 7C, question number 13, the answer is 4, comma, minus 1. So our answer is perfect. I hope you understand. You see, an equation was given, and it's a cubic equation. And this is the first question we have done. And an equation was given. There were some points given. He said that the normal at the point A and the normal at the point B intersect each other at the point C. So we derivated that equation, and then I put x equals to 1 and found the gradient of the tangent there. Then I found the gradient of the normal there. Then I found the equation of the normal at the point A. Then in the expression of the derivative, I put x equals to minus 2 and found the gradient of the tangent. Then I found the gradient of the normal at that point. Then I found the equation of the normal at that point. So these two equations, then we solved them. So when we solved them simultaneously, so the answer was the point of intersection of these two normals. That is the point C, they said, and its coordinates are 4, comma, minus 1. The answer is perfect. I hope you understand. I will put this video. The recording will be there available in my channel. Okay, so there is no problem. Okay, so we are going to the next question. The next question is question number 14. He says a curve has an equation. A curve is given. So we are talking about now question number 14. Okay. Question number, this is exercise 7C. And it's question number 14. This is the 4th episode on it. Okay. He says the curve has an equation. Here a curve is given, which is y equals to 5 divided by 2 minus 3x. And passes through the point P. Here a point P is given. The curve passes through this point. It is minus 1, comma 1. Find the equation of the tangent to the curve at the point P and find the angle this tangent makes with the x-axis. Okay. So we can find this. You see, first of all, we need to derivate this. We have to find the equation of the tangent first of all. So first of all, I will bring this upstairs. So y will be equal to 5 into 2 minus 3x raised to power. I brought it upstairs. Now I will derivate it. Okay. So y is equals to 5. This power will come on the side, and the power will be decreased by 1. So that's why the power will become minus 2. Then I will take the derivative of this base. The 2 derivative is 0. Minus 3x's derivative is minus 3. So y will be equals to this minus becomes plus. 3 5s are 15. So I write 15, and this comes downstairs because the power is negative. Downstairs, its power will become positive. Sorry, I have to write dy by dx. dx. So this is dy by dx. Okay. So we found the derivative of that expression, that given equation of the curve, and now we will put this point and find the gradient of the tangent. So x equals to minus 1. So I will put that in this equation. So 15 divided by 2 minus 3 into minus 1. So the whole thing, and here we have square. So you will have dy by the dx equals to 15 divided by, this becomes 2 plus 3 and its square. So this becomes 5. 5 square is 25. So we will have dy by the dx equals to 15 divided by 5 square is 25. You cancel them. So you will have 5 3s are 5 5s are. So this is the, so you see the gradient of the tangent is 3 by 5. Okay. The gradient of the tangent we just found. Their question is find the equation of the tangent to the curve at the point P. Okay. So we have to find the equation. The formula for the equation, I know the gradient of the tangent. I know this tangent is at the point minus 1, comma 1. And I want to find out the equation. The formula of the equation is y minus y1 equals to m bracket x minus x1. So the equation of the tangent will be y minus y1 equals to m bracket x minus x1. Okay. So then you see, I know that I will put this P point there, and the gradient is this 3 by 5. I hope it's right. Y minus y1 gradient is 3 by 5 into x minus and minus 1. Okay, so this becomes y minus 1 equals to 3 by 5x. Sorry, this becomes 1. So this is y minus 1 equals to 3 by 5x plus 3 by 5. So y will be equals to 3 by 5x plus 3 by 5 and plus 1. So y will be equals to 3 by 5x plus, this becomes 5, 5 and 3, 8, 8 by 5. You can use your calculator. Calculator is allowed in this paper. So 3 by 5 plus 1, that will be 8 by 5. Okay? If you do not do mentally, then you can use calculator. 3 by 5 plus 1, that will be 8 by 5. So this is the equation of the tangent. This is their first question to us. So it says it will be y is equals to 0.6. That's right, 0.6x plus 1.6. Okay. So they have written this in the decimal form. So y will be equal to 0.6x plus this is 1.6. You see, 3 by 5 is 0.6 and 8 by 5 is 1.6. So this is the equation of the tangent, and I have checked the answer, that is correct. Then they say, find the angle that this tangent makes with the x-axis. You see, if you have a equation of any straight line and you want to find what is the angle this making with your x-axis, the method is very simple. You just take its gradient. The gradient is 0.6. You make it equals to tan of theta. That is equals 0.6. So theta is equals to tan inverse of 0.6. Use your calculator, and we will use our calculator and find what is the tan inverse of 0. Simply, you see, if you want to find out the angle that line makes with the x-axis, you take the gradient of that line and you make it equals to tan theta, and from there get the value of theta. Okay. So on my calculator, I will do shift tan 0.6 bracket close equals to, in the degrees, the answer is 30.9. And I don't know if they are wanting 30.9 is the right answer, 30.96. The answer is in degrees, okay? So 30.96 degree. So this is how you find it, okay? So you see, we are done with the question number 14. The answers are right. So in the question number 14, what they did, they gave us an equation of a curve and a point P, which was on the curve, minus 1, 1. They asked us to find the equation of the tangent at the point P. Once we found the equation of the tangent, then they ask us find the angle that the tangent makes with the positive x-axis. And the gradient of the tangent, you take that, you make it equals to the tan theta, and from there theta is equal to tan inverse of that gradient, and that gives you the angle that line, that tangent makes with the x-axis. So I hope you understand. So this was question number 14. We are working on the exercise 7C, which is about the tangents, normals, and the main topic is differentiation. We are doing pure maths 1, and this is AS A levels mathematics 9709. This is the 4th episode on the exercise 7C. I hope this question is clear to you. Let's move to the next question. Okay, so now we are going to the next question, that is question number 15. So question number 15, we are working on the exercise 7C. You see, this is exercise 7C, and it's question number 15. Okay. So the question number 15 says that The curve, here a curve is given. The equation of the curve is given that the y is equals to 12 divided by 2x minus 3 minus 4. This is the equation of the curve. The curve y equals to 12 divided by 2x minus 3 minus 4 intersect the x-axis at the point P. The tangent, so this cuts the, it cut the x-axis at the P. Okay, this curve cut the x-axis at the point P, and the tangent to the curve at the P intersects the y-axis at Q. Find the distance PQ. Okay, so you see, first of all, I can find, when any curve or a line cuts the x-axis, the y is 0. Okay, so in this equation, put y is equal to 0 because of this. Okay, so 0 will be equal to 12 divided by 2x minus 3 minus 4. So 4 will be equal, this 4 comes here. 12 divided by 2x minus 3. So 8x minus 12 is equal to 12. So 8x will become 24. So the x will become 24 divided by the 8, and x will become 3. So the point P, its coordinates are 3, 0. Now, then I will derivate this equation. This is the first portion. Because that point P was on that curve, and the P is the point where this curve cuts the x-axis. So when a curve cuts the x-axis, the y is 0. Its y coordinate is 0. So what we will do in that equation, wherever is the y, we will put 0. So 0 is equals to 12 divided by 2x minus 3 minus 4. So from there we found the value of the x, and that is 3. So the coordinates of the point P are 3, 0. So now I will find the equation. They are talking about the tangent to the curve at the point P. So first of all, I will find the, so you see this is y equals to 12. I will bring this upstairs, 2x minus 3 whole raised to power minus 1, then minus 4. Then I will derivate this. Let me derivate it here. dy by the dx, and that will be equals to 12 into minus 1 into 2x minus 3 raised to power minus 2, and then 2x derivative is 2, minus 3 derivative is 0, then minus 4 derivative is 0. Okay, so dy by the dx will be equals to 2 minus 12 minus 24 divided by 2x minus 3 and its square. Okay, so you see I derivated that curve, its equation, and now let's check if this is right. Okay, it's perfect. Okay, so at P, at x equals to 3, so the dy by the dx will become minus 24 divided by 2 into 3 minus 3 and its square. So this will become 24 divided by, this is 6, 6 minus 3 is 3 square is 9. So 3 8s are, 3 3s are. So this is how you will find the gradient of the tangent at the point P. And according to my calculation, it is 8 by 3. That's the gradient of the tangent. Now I can find the equation of the tangent. Okay. Now we can find the equation of the tangent. The equation of the tangent we can find easily at the point P, the equation of the tangent. So the equation of the tangent will be y minus y1 m into x minus x1. The point is this 3, 0, and this is the gradient of that tangent. So y minus 0 is equals to, the gradient is 8 by 3 into, and it has a negative, yeah, it has a negative, so negative, yeah. So x minus 3, okay, so y will be equals to minus 8 by 3x plus 3 will be cancelled, you're left with the 8. So this is the equation of the tangent. Their question was, the tangent to the curve at the point P intersects the y-axis at Q. Find the distance PQ. Okay, so this tangent cuts, this tangent cut the y-axis at the point Q. So when you see, when some line cuts the y-axis, the x will be 0. So here the x will be 0. So y will be equals to minus 8 divided by 3 into 0 plus 8. In the equation of the tangent, in the place of x, I will put 0, because when you cut the y-axis, the x is 0. So this thing becomes 0. So y is equals to 8. So the coordinates of the q are 0, 8. Okay. So this is the point Q where the tangent cuts the y-axis. Then they say find the distance between P and Q. They want me to find out the distance between the P and Q. You know the formula for the distance is x2 minus x1 whole square plus y2 minus y1 whole square and under root on it. So 0, and the point P is 3, 0. So this will become, so let's say the 0 minus 3 and its square plus 8 minus 0 and its square and a square root on it. So this is 3 square, that's 9, 8 square is 64. So this becomes 73 and its square root. And I can find the square root of the 73, or you can leave it in the third form. So we think that in the book, the answer is under root 73. So the answer is good. It's right, sir. So you see, try to understand the question again. This is question number 15. A equation of a curve is given. He says that the curve passes through a point P. At the point P, the curve cuts the x-axis. You see, when you cut the x-axis, the y is 0. So in the equation of the curve, in the place of the y, I will substitute 0. And from there, I will get the value of the x. That will give me the coordinates of the point P. So the coordinates of the point will be 3, 0. Then I derivated the equation of that curve. And once I derivated it, in the place of x, I put 3 to find out the gradient of the tangent at the point P. So we found the gradient of the tangent to be minus 8 by 3. Then we found the equation of the tangent at the point P. So I used point P and the gradient. And we found the equation of the tangent. Then they said the tangent cut the y-axis at the point Q. So when the tangent will cut the y-axis, the x will be 0. So in the equation of the tangent, in the place of x, I put 0. So from there, I found the value of the y. So the coordinates of the point Q are 0, 8. So now I know the coordinates of the point Q and I know the coordinates of the point P. In the end, they ask us to find the distance between P and the Q. You know the coordinates of the P, you know the coordinates of the Q. You apply the distance formula and you find the distance between them. Our answer is under root 73, which is right. I have checked it from the book. I hope this is clear to you. This is question number 15 from the exercise 7C, and this is the fourth episode on this exercise. The topic of the exercise is the tangents and the normals. The main topic is differentiation. This is pure mathematics 1. You see, the idea of these videos is that we make these videos, we are solving the course book. The idea is that these will helpful for the weak students. Okay, the brilliant students, they don't need to practice the course book. They can comprehend the concept by just practicing their topicals. But the weak students, they grasp the concept when they do basic level questions, then intermediate level questions, then advanced level question, and do a lot of questions, and then they are able to grasp that concept. Okay, so now we are going to the next question. That is question number 16. And let's go to the next question. So that is question number 16. And by the way, this is the last question of this exercise. So exercise 7C after this question will be completed. He says the normal to the curve. This is question number 16. This is the exercise is 7C. And he says the normal to the curve is given. Y is equals to 2x square plus kx minus 3. At the point is given here 3 comma minus 6 is parallel to the line. The normal is parallel to the line. A line is given here. The equation of the line is x plus 5y is equals to 10. Okay. He says that the normal to the curve y equals to 2x square plus kx minus 3 at the point 3 comma minus 6 is parallel to the line x plus 5y equals to 10. Their first question is find the value of the k. Okay, so no problem. First of all, I will, from this line, because the normal is parallel to this line, so I will find out what is the gradient of this line. So I will make this y the subject. So this will become minus x plus 10. So y will be equal to minus 1 by 5 into x plus 10 by 5. So the gradient of this line is minus 1 by 5. The gradient of the normal will be also minus 1 by 5. Why he said, why the normal will be, the gradient of the normal will be also minus 1 by 5, because they said that the normal is parallel to this line. Okay. So at this point, the gradient of the tangent will be reciprocal of this and sign change. Okay. Now I want to find the value of the k. So I will bring the equation of the curve, that is y is equals to 2x square plus kx minus 3. I will derivate it, dy by the dx will be equals to 2 into x plus k minus 0. So dy by dx will be equals to 4x plus k. So at the point, this point, which is 3, at x equals to 3, this is the gradient of the tangent there. So it will become 4 into 3 plus k. And we know that the gradient of the tangent will be 5. So from here I can find 5 minus 12, and that will be equals to minus 7. So the value of the k will be minus 7. So let me check. The value of the a part is minus 7. So the answer is correct, sir. This is the a part. Question number 16, its a part is completed. We have to find out, the question was find the value of the k. So the value of the k is minus 7. Okay. Then they say find the coordinates of the point where the normal meets the curve again. Okay. So find the, first of all, I will find out the equation of the normal, and then I will solve the equation of the normal and the curve. Okay. So equation of normal. Okay. That will be y minus y1 equals to m bracket x minus x1. This is the formula to find the equation of the normal or any line. The normal is at this point, and the gradient of the normal is minus 1 by 5. So y minus 6 is equals to minus 1 by 5, and x minus, what is x1? That is 3. Okay, so it will be y plus 6 equals to minus 1 by 5 x plus 3 by 5. So y will be equals to minus 1 by 5 x plus 3 by 5 minus 6. So y will be equal to minus 1 by 5 x. This is 30. 3 minus 30, that's minus 27 by the 5. So this is the equation of the normal. So they ask us to find the point at where the normal intersects the curve again. So take the equation of the curve, take the equation of the normal, and solve them simultaneously. Okay, so you will find the point of intersection between the normal and that curve. Okay, this is the equation of the normal. The equation of the curve is y is equals to 2x square plus the value of the k is minus 7. So it will become minus 7x minus 3. So this is the equation of the normal. This is the equation of that curve. So we will solve them simultaneously. Both are equals to y. So I will make them equals to each other. So this is equals to x by 5 minus 27 by 5. Okay. So multiply every term with this becomes 10x square minus 35x minus 15 equals to x minus 27. You see, I multiplied every term with the 5 to get rid of that fraction. Now I have 10x square minus this and this becomes 36x minus 15 and plus 27. So 5 and 7, that will be 12. So it will be plus 12 equals to 0. Okay. So am I right? Yes. So you can take 5 common. No, not 2 common, x square minus 18x plus 6. So this is so you get 30, and from 30 I can find the value of the means adding. This is 12 into 6. No, with midterm breaking cannot be done. Let me check the answer. The answer is in decimals. Okay, so am I right? Am I doing it correctly? Okay, so this was 2x square. Okay, minus 7x. Okay, minus 3. This equation was minus, oh yes, I forgot this negative. You see, I made a mistake here because the numbers have become a little strange. This is negative here. You see this negative here. So this is negative. So when this thing come here, this becomes 34. If this is 34, then it will be 17. Now 12, 15 twos are, yes, now it can be x square minus 15x minus 2x plus 6. I did the midterm breaking. I forgot to put a negative here. Okay, so 5x x minus 3 minus 2 x minus 3 equals to 0. X minus 3, this is 5x minus 2 equals to 0. So this will become x equals to 3. This will become x equals to 2 by 5. This point is already given to us, so I'm going to work on it. Okay, this is the other point. This point is already here. Okay, now if the x is equals to 2 by 5, then I need to find out the value of the y of that point. Okay, so let's use any equation. Okay, I'm going to use this one. So y will be equals to minus 1 by 5. The value of the x is 2 by 5, and then you have minus 27 by 5. Okay, in this equation, in the place of the x, I'm putting 2 by 5. This x3, that point is already here. Okay, so the other point is this one. So the y will be equals to, let me have some space. This will become minus 2 by 25 minus 27 by 5. So you can use your calculator and find the value. So 2 by 5 is 0.4. Okay, so I'm going to use my calculator. Minus 2 divided by 25, then you have minus 27 divided by 5 equals to, and this is minus 5.8. So in the fraction, it is minus 2 divided by 25 and minus 27 divided by 5 equals to, and this is minus 5.48. So this is 0.4. So the coordinates of that point will be 0.4 comma minus 5.48. So this is that second point where that curve intersects the that normal intersects the curve again. Okay, the one point at where the normal touches the curve is intersects the curve is 3 comma minus 6. That point was already with us. So we are done with the question number 16. The answers are correct. I have checked this answer. 0.4 comma minus 5.48 is the right answer, sir. That's in the book, and I hope that this is clear to you. You see, this was the 4th episode on the exercise 7C. This is the course book of the Pure Mathematics 1. This is AS and A levels Mathematics 9709. We are working on the solutions of the course book, and we are done with the exercise 7C. We have done each and every question of the exercise 7C. I hope that this will be helpful to the students who are watching of the AS, who are watching this video, and especially these videos are for the weak students because they need to work on the course book. In the course book, the question goes from the basic level and gradually their difficulty level increases. And by doing the course book, the weak students can also grasp the concept. And if they do the practice, if they do each and every question, then their mathematics will improve. Their grades will improve. I hope that this video will be helpful to you. So thank you very much for watching this video. And please share the link of this video with your friends, with your class fellows, with those students who are struggling with the AS Pure Mathematics 1. It's a great blessing for me that I can make these videos. Your support is very important. Like this video, share this video, subscribe my channel. Thank you very much. Have a good night. Thank you. God bless.